record. So in fixture, there are 5 main vertices. One is process design. It's a theoretical study before starting any design. In each industry, we are doing the planning for the manufacturing point of view, for construction point of view, design point of view. So all the planning stage, it's called process. So these are the theoretical documents. We will create some theoretical 7 to 8 documents, and we will study what covers in the document. So these documents mainly created by OEM companies or tier 1 companies. OEM is original equipment manufacturing. Those who having their models like Tata Motors, Maruti, all this. And tier 1 supplier. Tier 1 supplier means from OEM, the projects will go to tier 1 supplier, and tier 1 supplier will do the design, manufacturing, tryouts, and installation process. So the scope of work of tier 1 companies. So these are the OEM, these are the tier 1 companies, and these are the service industry. Service industry having the scope of work only IT industries, 2D and 3D. No installation, no tryouts. So these are the companies all over India. So more than this, there are lots of companies in now BIW Fixture Designing. So your future and scope is very good, because you can switch the company and your package will be increased by 20 to 30%. So this is the main advantage, having more companies. So first is process. It is mainly created by experienced people, mainly 5+ experience. But if you work in small scale company, then you can create a you have to create a process document as well. So first is process. After process, then we will go for 3D finish. 3D concept means 3D design. So process is a guideline for design engineer. So we follow the guideline and we start the design. We use some reference data given by client, and we will start the modeling. After completing the basic modeling, we will do the analysis. So many companies, they are using thumb rules for thickness, for length, and some companies doing the proper analysis by using ANSYS and other softwares. So in that, we will check what will be the dimensions for the part, maximum, minimum dimension for the part, so that it will not break while working. So this is one task. Second task is we are going to use pneumatic cylinders and manual clamp. No hydraulic, no electric, because pneumatic is a fast moving action. So cycle time, for us, cycle time is more important, because we are doing for a mass production. So considering cycle time, we are using pneumatic cylinder. So as a design engineer, we will check whether that cylinder applying sufficient force so that the panel or workpiece can get hold. If there is a less force, then there is no use, because that cylinder cannot clamp the particular workpiece. So that's why we have to check, and by checking, we have to prove to the client. So if we use standard cylinders, purchase cylinders, so cylinder manufacturing company, they will give us some reference data, some documents. So by using that document, we can check and we can prove that that cylinder is okay for particular application. So we have to do the hand calculation. So if clients are other than India, means Tata Motors and outside clients, they are using proper systematic cylinder, so that designer work will be less. And other companies like Maruti Suzuki and Indian companies, Fiat and all these companies, they are using simple cylinder, so that cost of the project will be less, but the work of the designer will be more. So we have to create linkage mechanism. So by using linkage mechanism, we have to apply the proper force. So project cost will be less, but designer work will be higher. So we will take all these things, because in linkage, if any link is less or there is any problem, that it won't work, it will lock. So we have to check for working, for force, and for proper opening angle. So there are more calculations as compared to foreign clients. So we will check
that will be taught, no sir?
Yes. because
Okay, sir.
most of the Indian companies using this. So in this project, we will cover Indian standard and European standard. As we
Okay.
discuss Indian
Hello. Hello.
considering design view, Indian standards are critical.
Okay.
Considering manufacturing, suppose you are working in a manufacturing team. So
Yes,
Indian
sir.
standards are very easy because as a design engineer, we are providing all the information for manufacturing person. So that
Okay.
is the main advantage of Indian standards. So this is critical for design engineer and other clients like European clients. They are providing, they have some proper systematic format. So only they are providing only that much dimension. They will not provide any tolerance and all these things. So it is easy for design engineer. So first we will check critical one and then we will shift for simple one. Okay.
Okay, sir.
So this is a concept design. After concept design, all the calculations and all the proven, then our fixture is ready. Then we will check for a working. So mainly in this course, we will check welding. So here welding is geometric welding, geo fixture and re-spot fixture. These are the main two types for welding fixture. So what is
Okay.
geo and what is re-spot? Geo
What is
means
geo and
geometric. Geo, geometry,
geo and
geo and re-spot.
respot? Okay, sir. Okay.
Okay, so geo means suppose we want to weld two parts in garage or in any shop floor. You observe that that particular person, he will clamp the two parts. He will take outside 4 to 5 spot. Then he will unclamp that part and he will take the remaining spot.
Yes, sir.
So at first stage, he is taking outside 4 to 5, depending on the length and area of the panel. He will take some spot
Yes, sir.
and then he will release the clamp. So while taking the spot, clamp is there. So it is a geo spot, means geometry is fixed. We are creating a geometric fix.
Yes, sir.
After fixing a geometry, the clamp is open. So there is no need of clamp and remaining spot will be taken. So that is called re-spot.
Okay. 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 Okay.
Okay. So basic spot which is required to hold or which is required to fix the part,
Hello.
it's called geofix, and remaining spot which are taking after releasing the clamp or in some another stage, it's called re-spot.
Okay,
Re
sir.
means again, okay, which are pending, we are taking into the next location. So it's called re-spot. So
Okay,
these are
sir.
the main two types. And we will check whether that welding tool, welding gun, it's called gun, welding gun is working, it's reaching towards the destination, means where we have to take the spot. At that area, there should not be any parts. Okay, if there is a parts, what we are created, so that gun or that tool will foul with that parts. So we have to check whether that is fouling, how much clearance is there. All the clearance table, clearance chart will be provided by client or customer. So we have
Okay.
to check that. So initial level, there will be fouling, there will be issues. So as a simulation engineer, suppose we are working in a simulation team. So as a simulation engineer, we have to check whether that gun is going at that particular place or is there any fouling. So we have to check all the things. We have to create one PPT document and we will send to the design engineer.
Okay,
So
sir.
as a design engineer, we have to clear all the fouling by using Catia or software modeling, pocket and all these features. So we will avoid the fouling.
Okay.
After clash-free design, we will go for 3D finish. So in 3D finish, we will check how to assemble number of parts. And suppose there are assembly of 2 parts. So how to assemble, how many dowels we should use, how many bolt we should use, how to add machining step, where to add machining step, how to reduce the cost of the project. So cost optimization is there in 3D finish. And after 3D finish, we'll go for assembly point of view drafting. There are two types of drafting: assembly point of view drafting and manufacturing point of view drafting.
Okay, sir.
In assembly drafting, we will cover proper systematic way so that when parts are manufacturing, we can assemble at a particular location. Okay,
Okay, sir.
just a hold 1 minute.
Okay, sir. Hi, sir. Tell me, sir.
Yes, one phone is there. So okay, so this is the main our what you can say the procedure or the steps which are followed by the companies. Okay,
Okay,
so
sir.
these are interdependent, but in companies we can directly get project for 2D, we can directly get project for only 3D, only 2D, only 3D
Okay.
finish, only simulation. Okay, so
Okay, sir.
this is the scope of work as per the companies. Now we will go for the fixture designing theory. Today we will go for theory. Then from tomorrow I will share the data. We will start theory as well as practical, both things simultaneously.
Okay, sir. So these
What is
things,
fixture?
like this PPT will be shared with us, sir. Like any
No,
document.
this video I will share. So you have to create the notes on your own language so that when
Okay.
you go for the interviews, you just read out that book.
Okay, sir. Okay, sir. Fine.
Okay. You are from Hyderabad or Bangalore?
Bangalore, sir. Bangalore.
Okay. Yeah, okay, no problem. So fixture. So what is fixture? So fixture is a basic device which can support, locate, hold the workpiece so that we can do the various operations, different operations. So depending on the operation, the fixture type or fixture name will be there. Suppose we are doing drilling operation, so it is drilling fixture, machining fixture, hemming fixture, so sealing fixture. So these are the different. If we are checking only doing the checking, so it's called checking fixture or inspection fixture, inspection. So these are the basic types. So main thing of the fixture, main purpose of the fixture is for the mass production. Second, to restrict all the degrees of freedom of our workpiece so that we can do the accurate process on that. We can do the what operations, perfect operation or precision operations on that particular object. So basic advantage of using the fixture, machining accuracy. Take a simple example, drilling. If you are doing the drilling without any fixture, means without fixing the part, so what will happen? The part on which we are going to drill workpiece. So on that workpiece, accurately we cannot do the operation because part is not fixed. It is moving. It is vibrating. So accuracy will not be there. Then second thing, if we want to create number of parts or mass production, suppose in 1 hour we want 10 to 15 parts or 20 parts should be drilled exactly at the same location. So without using fixture, we cannot achieve this. So that is for high production, mass production. We want fixture so that time of clamping and holding will be reduced. Then operation convenience and safety. So simple example again, drilling. If you are not holding the workpiece, then it can rotate with the drill. It again, if it is vibrating, the tool or workpiece may get break and it will be issue for the operator, safety issues. So for that we will fix the part by using fixture, and again extend the manufacturing ability and machine tool. So as discussed, if part is vibrating, so drill can break or it may wear out quickly. So if it is a fix, then tool life will be increased. So that is the main function or main reason why we are going to use the fixture. So in any industry where the operations are there, this fixture is using. So we mainly focus on automobile BIW, but same concept is applicable to any industries. Little bit different standards. Okay.
Okay, sir.
So it is a basic 3-to-1 principle as we studied in engineering.
Yes, sir.
Okay. So primary datum, secondary datum, tertiary datum.
Yeah.
Okay. And this is actual. So we will check actual 3-to-1 principle.
Okay.
This is our workpiece or panel. So in automobile industry, workpiece is called panel. So this is our panel.
Okay.
So total degrees of freedom 6 or 12. 6 means 3 rotational, 3 translation.
Yes,
12
sir.
means plus minus, if you consider plus minus, x plus x minus, so 12. So total 6 degrees of freedom are there. So basic principle of fixture is 3 to 1.
Yes, sir.
3 to 1 principle. So by using 3 to 1 principle, we are restricting, we are holding the part with 0 degrees of freedom. So how actually to work, we will check. So this is our workpiece or panel. So these are the rest. Okay, it's providing support from bottom side, and on that from top side we are clamping by using pneumatic or various operations. So rest and clamp. So we are providing number of rest and clamp. In this diagram it is shown as 3. Okay,
Yes, sir.
so simple example, our tripod, civil tripod or camera mobile tripod. So if part length or dimensions are less, so by giving 3 supports we can stable that part. Simple example, our mobile, uh, keep your fingers at 2 corners, suppose 2 edges, and one finger at 1 minute. I will show the diagram. Okay, suppose this is our mobile. So support, one support is here, second support is here, and third support is here. So by using these 3 supports, we can balance the part. But suppose we only use 2 supports, this and this. So it will create our axis.
Yes, sir.
And along this axis, this part can rotate. But
Yes,
if
sir.
you add 3 non-collinear supports, so it will create a plane. And by using that plane, our workpiece or panel object will be stable. So
Okay,
that's
sir.
why minimum 3 support if part is small. If
Okay.
part length or dimensions are more, then we want more supports, because if the length is suppose 1 meter, 2 meter, 10 meter, so if you provide supports at end only, then here sagging will be there. Part will bend like this.
Okay, sir.
Okay, because panel or workpiece thickness is less, then it will sag. So that's why depending on the area, number of supports may increase. So this is
Okay,
an
sir.
example. So that's why given 3.
Okay, sir.
Many people, many candidates assume that these 3 and these 3 is same. 3 means 3 supports. Okay, so 3 means not 3 supports. Okay, number of supports may be 1 or 2 or infinite depending on the area. Suppose
Yes,
part
sir.
is very small part, so only one support will be sufficient.
Yes,
So
sir.
now we will see what is 3. Now these are the number of rest and clamp we are provided. So
Okay.
rotary motion, this rotary motion, and this linear motion, means one linear and 2 rotary motion we are locking by using this rest and clamp. So
Okay.
that's why 3, one linear and 2 rotary motion lock. So total is 3. So that is called 3. 3
Oh,
means 3 motions. We are restricting 3 motions.
okay, sir.
Now 2, we will go for 2. So here is a panel having circular hole, and in that hole exactly circular pin is attached or placed. So
Okay.
this linear motion and this linear motion is restricted by using this pin. So
Okay,
two
sir.
motions, two linear motion restricted by using this pin. So two means for 2 linear motion. Now here 3 motions, here 2 motions, total 5. Now only remaining motion is along this pin axis. This panel can rotate.
Yes, sir.
So we have provided one pin here. So it will act as an anti-rotation, or it will restrict our rotary motion.
Okay.
So that's why it's 1. And
Okay.
if you observe, here is elongated hole and pin is normal circular pin and elongated hole. Means suppose we insert only this pin.
Okay.
So this panel having this direction motion, this linear motion,
Okay.
because there is a slot. Now consider if panel having same round hole and round pin, same round hole, round pin. So this pin restricting 2 motion. Same feature, same concept applied here. Then this pin also restrict 2 motions. This
Okay.
rest and clamp, it will restrict 3 motions. So 2 plus 2, 4, and plus 3, 7.
Fine. Yeah.
7 motion will be locked. We have 6 motion, means one motion will be extra or repeated. So it's
Yes,
called
sir.
over constraint.
Okay.
So that's why in panel it is provided slot. If in panel there is a round or normal hole, then we have to create a geometry or we have to create a pocket in this direction so that this motion will be free for
Okay.
another pin. So this is called primary pin, this is called secondary pin. Clear?
Okay, sir.
All these things we will check or we will see while doing the modeling or designing.
Okay, sir.
So these are the basic degrees of freedom, linear and rotary. Okay.
Yes, sir.
Jigs and fixture. So fixture we already checked. To restrict the degrees of freedom, we use fixture. In that we locate, we clamp and we support the workpiece. So this is a function of fixture. Jig
Yes.
perform all the same function, but additional one thing, it is also used for guide the tool. Means it will secure our part, it will secure the degrees of freedom of our part as well as it will guide the tool. So performing extra function guiding the tool. So it's called jig. Okay.
Sir.
Now this is a material. Most important thing, that's why covering in first lecture, material.
Okay, sir.
Now what is mylar? So in this actual degrees 3 to 1 principle, we check this is our panel and this panel having rest and clamp. So these are the direct contact with our panel or workpiece, and there will be some other parts and which are going to the ground. So this
Yes,
is
sir.
one assembly. 1, 2, 3, 4, 5. So number of assemblies will be there, number of parts will be there. So out of that parts, the parts which are in contact with panel, it's called mylar.
Okay, okay,
Clear?
okay. Okay, sir. The
These
parts
are
which are
the
contact
assemblies.
with panel.
Yes,
Okay.
the parts which are directly contact with panel, it's called mylar. The remaining part will not be directly contact with mylar. Sorry, panel. So the part which is in contact with panel or workpiece, it's called mylar.
Mylar. Okay, sir. Mylar. Okay.
So it's mylar, depending on the workpiece or panel area, mylar number will be increased. So there are basically two types of mylar. One is rest mylar, another is clamp mylar. Rest means it will give the support to the panel or panel will rest on our that mylar. So its function is rest or support to the panel. So that is why name is rest mylar. Second,
Sir.
clamp. So we are using pneumatic or manual clamping. So on that clamp, the mylers will be there. So that is called clamp mylar.
Okay.
Working, depending on function, clamp and rest mylar. These are the basic two types. Now material.
Sir.
This is a C45. C45 means what? It is an alloy having
Yes, sir.
carbon percentage. So
Okay, sir.
what happens if we increase the carbon percentage in
Increase
base
the
metal?
strength. Increase the
What?
strength of the material.
Strength or hardness?
Hardness. Yes, sir.
Okay. So if hardness uh, if hardness is less, then what is the problem?
A wear out will be tech, sir.
Right.
Usually wear out tech.
Okay. Wear out. So where exactly wear out will happen?
At the contact of the panel and the this one, sir.
Okay, means at contact, right?
Yes, sir.
Okay. If both parts are fixed, then there is any wear and tear.
If both parts are fixed,
A simple
no,
example: your table, computer table,
yes, sir,
having top and having legs. So legs are in contact with this top. So in between that, there is a wear and tear.
no, sir.
So where exactly wear and tear happen?
When there is a motion, they are only
Right. So
yes,
either both part or one part. So in
one
our
part.
case, where is motion? We are clamping, we are resting this part. After
Yes, sir.
completing the particular operation, this panel will be move out and another panel will kept here. So
Yes, sir.
continuous out and in panel will be there so that
Yes, sir.
this area will be wear out.
Wear out.
To
Yes, sir.
avoid wear out, not we can say avoid, to minimize the wear out, we are using carbon percentage higher. So C45
Okay.
material is used now all over industries. Before that, I think 5 to 10 years back, C40 was the material. Now C45.
Okay, sir.
Then nylon and Teflon. So these are the soft material. So
Yes, sir.
now here we are using hard material to avoid wear and tear. Now here we are using soft material, so wear and tear will be higher. But
Yes, sir.
this material we are using at a particular area only, where
Okay.
skin panel means car outside surface, door,
Okay.
roof. So these are the parts which are visible to the uh, visible from outside. It's
Okay.
called class A panel or skin panel. This
Okay.
is a metal, and this is a what you can say, non-metal, soft material. So if there is a
Okay.
metal to metal contact, there are chances to create a dent or to create a scratch.
Yes, sir.
So outer surface which are visible to the customer. So if there is a scratch, so customer will not buy that car or that part. So that's why
Yes, sir.
the part which are skin panel or which are visible from outside, in that area we are going to use nylon or Teflon.
Okay.
Okay, so that scratch and dent will be avoided.
Okay, sir.
Next, pin. Okay, so pin means these are the pins. The main function of pin is to locate the part or panel. Okay, so exactly pin is fixed at particular location and panel is coming and exactly locating on this or exactly doing the assembly with pin. So the location of panel will be secured by pin. So it's also called location, pin or location. So material is 20 mm CR5. So this is a round shape having various steps, one, two, three, number of steps. So if we are using C45, it is a hardened material.
Yes,
So
sir.
if it is a hardened material, we cannot do the machining, or machining will be critical, or we have to use hardened tool for that machining. So cost of the machining will be higher. So
Yes,
that's why
sir.
this alloy 20 mm CR5. This is manganese and chromium.
Yes, sir.
Increase in the percentage of manganese means easy to machine.
Okay, sir.
Machinability of that part will be increased. We can easily machine. And chromium, corrosion resistance. So part corrosion resistance property will also increase. So to do the machining, we are using 20 mm CR5. This is available in round shape. These are available in plates
Yes, sir.
C45.
Okay,
Okay,
sir.
and all the remaining parts in our assembly are normal base metal, SS, MS, or aluminum with grade. So client will give SS 400 or MS. So client to client grade will be vary, but we will use simple part so that cost of the material will be reduced.
Okay, sir.
Okay, and now see this. Now this panel will be coming out or going in along this axis.
Yes, sir.
So the whole of this panel and the diameter of the pin almost same. So it will all the time it will what you can say, it will create a wear out. Pin will be
Yes,
wear
sir.
out because of
Yes, sir.
friction. So that's why we are doing the hardening. So
Okay, sir.
this hardening process is case hardening. Case hardening
Yes,
means
sir.
up to certain depth,
Okay.
0.8 to 1.2 mm depth. Because if you go for throughout hardening, hardening means
Okay.
simple example, we are heating the part to the
Part
particular temperature and suddenly cooling, quenching.
cooling, quenching. Yes, sir.
Yeah. So when we heat, the molecules will expand. When we cool, they will shrink. So
Shrink.
if there is, yeah, if there is shrink,
Void. Yes, sir.
yeah, so there will be chances of
Correct. Yes, sir.
cracking. So that's why at a particular depth, we will go for the case hardening, 0.8 to 1.2 mm depth only. And the hardening
Okay.
value is 55 to 60 HRC.
Okay, sir.
Okay. And leave thread soft. Why threads are soft? Because if part is hardened, it is easy to break, or brittleness. If
Yes, sir.
part hardness is increased, is brittleness also increased. So threads will be easily break. So that's
Yes,
why
sir.
we cannot hard, or we will keep the area soft in the threaded area.
Okay, sir.
Okay, that's why we will not harden the thread. So it will easily break. Mylar C45 material. Here we will use induction hardening. Induction hardening means magnetic field. In the
Okay.
magnetic field, we keep our part, and due to the magnetic field, it will harden our part. Or second is flame hardening. Again, same note, leave thread soft, and its hardening compared to pin, it's less, 40 to 50 HRC. it's 55 to 60 because here
Where and
material is soft.
soft, yes, sir.
So that's why we do the higher hardening. Material is already hard, so that's why 40 to 50 HRC. So
That's
these are the
okay.
notes we have to mention while drafting.
Okay, sir.
Okay. So
Okay,
for
sir.
today's lecture, we'll stop here because this is the only theory. You write down
Okay.
this material. If you are having 5 to 10 year experience, in all interviews, this material question will be there. 3 to
Okay,
1
sir.
principle will be there.
Okay.
Why to use the fixture? These are the typical question, compulsory questions will be asked. So properly understand this part, understand the drawing, write down your own language, and
Okay,
if
sir.
you have any problem, we will discuss.
Okay, sir. Fine, sir. Sure.
Okay.
Okay, sir.
Anything else?
No, that's all, sir. So I'm getting the
Okay.
points, sir. I have noted down in the book right now. So you will share me the recorded video, sir, no? Like how it
Yes,
is?
yes. I will share the video. Just
Okay, okay.
share me the your mail ID.
Yes, sir. I'll do it. Okay.
And when you will going to pay the fees?